We are building the bit by bit project for the YByte Python curriculum available at www.ybyte.in. In the last video, we saw the bitwise AND operator. Let's now look at the bitwise OR operator. In fact, the view is actually quite similar. So we input two decimals, two integers into the function, and we get out, let's say, one output. Just like in case of bitwise AND, internally we look at the binary representation. We don't have to do it ourselves. This is happening inside the function. Both the numbers are converted to binary, but unlike the bitwise AND, now we do a bitwise OR. So basically OR between these two bits, and so on and so forth. Hence, we end up with again, and let's say equal number of bits in the binary representation of the output, but the function returns us the decimal equivalent to that. Once again, let's look at an example because examples make it much more clearer. We will do a bitwise OR between 43 and 157. The symbol is this pipe operator. Um, Remember, 43 is 00101011 and 157 is 100111101. Now, first we look at the binary representation of 43 and 157. Then we do a bit by bit OR between these, let's say these two numbers. So I get a 0 and 1, that's a 1, because remember in an OR gate, any of the inputs being 1 results in a 1. This results in a 0, this is a 1, this is a 1. This is going to be a 1 as well, because both being 1 is also a 1. So any one of them is 1 is sufficient to make it 1. And that's what we are seeing. In fact, we get all ones here. The result is 101111111. Remember, however, the function returns the equivalent decimal, and that is 191. In fact, we can see this. I get to, let's say, int, let's say 10111111, and base is, let's say, base 2 because of binary, that is 191. That is why when I did, let's say, 43, say, pipe, say 157, that gives me a 191 because it has done a bitwise OR between these two numbers. Now, before wrapping this up, I just want to highlight something interesting to you. You see this binary string 10111111. Now, of course, we can use, let's say, the method that we used here to get its value, but in fact, there's a very interesting way to do it ourselves orally. Remember, if I were to do int, let's say 11111111 base 2, this is 255, because remember, this is basically the largest number I can represent with 8 bits, and that has to be 2 to the power of 8 minus 1, which is basically 2 to the power of 8 minus 1, that is 255. Keep in mind that the place value of this is 1, place value of this is 2, place value of this is 4, 8, 6, and so on and so forth. So if I were to, let's say, subtract from this 255 minus, let's say, 64, that is 191. How do I see that in binary? Well, the bit whose face value is 64 must have become 0. And that's why int of, let's say, 10111111 is 191. So this is like kind of getting some more intuition into binary numbers. This develops with practice, but think about it, right? As always, learning things in a step-by-step logical manner is what we believe in and what we do at YByte. Do look at our website www.ybyte.in to find many, many interesting lessons about Python, and enjoy programming. Take care. Thank you so much. Bye-bye.